Now listen. Now come to the behaviors of these arithmetic functions. Some interesting behaviors. That is, we know that we have this result. Sigma over d divides n, according to the Mobius function, sigma over d divides n mu of d. What is this one? Sigma over d divides n mu of d is greatest integer 1 by n. Okay, this is a non-result. That is, sigma over d divides n mu of d equals greatest integer 1 by n means it is I of n, identity function. Agree. So this can be rewritten as sigma over d divides n mu of d means mu of d into 1. Okay, mu of d into 1 equals I of n. This 1 can be written as, we know that u of n equals 1 for all n. Since d be the divisor of n, then d runs through the same divisors of n by d also. So this 1 can be replaced by u of n by d, that is I of n. Okay, one is u of n equals 1 for all n, d be the divisor of n, then every divisor of n also runs through the divisors of n by d, so u of n by d is also 1. Therefore this 1 is replaced by u of n by d. So it is sigma over d divides n mu of d into u of n by d equals I of n. That means this is nothing but mu star u. Okay, by that, yes, we know that mu star u equals I. This is the Dirichlet convolution of mu and u. So mu star u equals I. Mu star u equals I means mu star u, the Dirichlet product of two arithmetic function is identity function means each of them act as inverse of each other. That means the mu inverse equals u or u inverse equals mu. Means mu and u are inverses of each other. Mu is the Mobius function, u be the unit function. So mu inverse is u as well as u inverse is mu. Okay. So this is an interesting behavior of the Mobius function and the unit function. Agree? Now by using these arguments, we can discuss an important formula which is known as Mobius inversion formula. What is Mobius inversion formula? The theorem says that if f of n equals sigma over d divides n g of d, f and g are any two arithmetic functions such that f of n equals sigma over d divides n g of d, then g of n equals sigma over d divides n f of d into mu of n by d. F of d into mu of n by d. That is, if f of n equals sigma over d divides n g of d, then g equals f star mu. What is the right side? F star mu. The reverse inversion also hold. This is also hold. That is, if g of n equals sigma over d divides n f of d into mu of n by d, then f of n equals sigma over d divides n g of d. So this is Mobius inversion formula. How to prove this one? The proof is immediate. Why? It is given the necessary arguments. Let g of n equals sigma over d divides n, let f of n equals sigma over d divides n g of d. Agree? So that means it is sigma over d divides n g of d into 1. Okay, that 1 can be rearranged as, or 1 can be replaced by u of n by d, because it is the unit function. The divisor, d be the divisor of n, which runs through all divisors of n by d. So that means f equals g star u, okay, by the Dirichlet convolution. Therefore, what is f star mu? Consider this f star mu. F star mu equals g star u star mu. But star is associative, so it is g star u star mu. what is u star mu? We know that u and mu, u inverse equals mu or mu inverse equals u. We see that mu inverse or mu inverse is u or u inverse is mu. Mu inverse is u means what is u? Mu inverse. So mu inverse star mu, that's an identity function. So G star identity is G. That means F star mu equals G. That means what is G of n? G of n equals F star mu of n. F star mu of n equals, by the Dirichlet convolution, it is sigma over d divides n, f of d into mu of n by d. That is, so necessary part is finished. Okay. What about the reverse inclusion? For reverse inclusion, just assume g of n equals sigma over d divides n f of d mu of n by d. That is the right side of this one. That means g equals f star mu. So g equals f star mu. So what is g star u? G star mu equals f star mu star u. But star is associative, so it is f star mu star u. But mu and u are inverses of each other, so mu star u is identity, so it is f star identity. F star identity is f. Means g of u equals f. Sorry, g star u equals f. So what is f of n? So that means from there, f of n equals from here, f star, yes, sorry, g star I equals f. G star u, not g star I, g star u equals f. So that means what is f of n? F of n equals, it is g star u of n. Again, by the Dirichlet convolution, it is our sigma over d divides n, it is g of d into u of n by d. But what is u of n by d? U of n by d is 1. So that means it equals sigma over d divides n g of d. So f of n equals sigma over d divides n g of d. That is the reverse inclusion. Okay. So this is the important or well-known Mobius inversion formula. If f of d is sigma, if f of n is sigma over d divides n g of d, then if and only if g of n equals sigma over d divides n mu of d into, sorry, f of d into mu of n by d. If not if and only if, actually it is, if f of n equals sigma over d divides n g of d, that implies g of n equals sigma over d divides n f of d into mu of n by d. Conversely, if g of n equals 31, then f of n equals sigma over d divides n g of d. Okay. So, also we know that. But is again we are going to the Mobius inverse, Mobius function. Now we are going to the Euler-Torsion function. What is sigma over d divides n phi of d? Sigma over d divides n phi of d is n. Okay, this is a well-known result. This is already, we proved this result. Sigma over d divides n phi of d equals d n, where phi be the Euler-Torsion function. We know that n of n is an identity function. So n of n is an arithmetic function which is defined as in this way. N of n equals n for all n. So this n can be replaced by n of n. That means n of n equals sigma over d divides n phi of d. What is Mobius inversion formula? The Mobius inversion formula states that if f of n equals sigma over d divides n g of d, then g of n equals sigma over d divides n f of d into mu of n by d, or g equals f star mu. If f of n equals sigma over d divides n g of d, that implies g of n equals, or g is f star mu. So in the light of this argument, we can say that if instead of f, here it is n. If n of n equals sigma over d divides n phi of d. Instead of f, here it is n, and g, here it is phi. So by Mobius inversion formula, what is phi of n? Phi of n equals sigma over d divides n. It is n of d into mu of n by d. Okay, that means what is phi? That means phi equals n star mu. This is another interesting result. Phi be the Euler-Torsion function, mu be the Mobius function, and n is an arithmetic function defined as n of n equals n. Then here we can say that phi equals n star mu. Okay. So, moreover, what is this phi of n? Phi of n equals n star mu of n. Okay, phi of n equals n star mu of n. But we know that n star mu equals mu star n. Why? Because it is the star is Dirichlet convolution is commutative. Mu of n means it is sigma. Mu star n means sigma over d divides n. Mu of d into n of n by d. Okay, sigma over d divides n, mu of d into n of n by d. That means that equals sigma over d divides n, mu of d into n of n by d is n by d itself. Agreed. So phi of n equals sigma over d divides n, mu of d into n by d. Okay. Or again we know that phi of n equals n star mu of n. If this can be rewritten as, this can be again rewritten as sigma over d divides n of d into mu of n by d. Okay, what is n of d? N of d is d itself. Why? Because n of n is n. So it is d into mu of n by d. This is the another result. Phi equals, or phi of n equals sigma over d divides n, d into mu of n by d. So this is another result, depends upon this Mobius function and the Euler-Torsion function. Okay, so these are some interesting relations regarding the arithmetic functions, that is with respect to their Dirichlet products. Agreed. Thank you.